Hello everyone, today let's solve the problem leaf partition, right? So this was asked in the forethought, this one future cup elimination round, right? So now you can just go through the question. It's very easy to understand and it's simple as well, right? So I'll just summarize the question so that it will be easier for us to solve the problem. Let's see what the question states here, right? So just give me a second, 1 second. Yeah, we have been given a rooted tree with n nodes, right? So we have been given a rooted tree with n nodes, right? So here I'll just go with root equals 1, right? So we have been given a rooted tree with n nodes, root equals 1, and leaves are nodes with no children. Leaves are nodes with no children, right? With no children, right? So I'll just go with, yeah, leaves are nodes with no children, right? So for any subset of leaves L, again, for any subset of leaves L, let f of L be the smallest connected subgraph containing all the leaves in L, right? For any subset of leaves L, let me write this one, f of L, right? Sorry, let f of L be the smallest connected subgraph containing all the leaves in L. So what we need to do then, we have to count the number of partitions. What we need to do here, we have to count this one, number of partitions. So I'll just write here par. This is nothing but the partitions, right? So we have to count the number of partitions of the leaves into the groups such that for any two different groups x comma y, the subgraph f of x and f of y are node disjoint, right? So this one, just keep this in mind. I'll just read this one out loud again. So we have to count the number of partitions of the leaves into the groups such that for any two different groups x comma y, the subgraphs f of x and f of y are node disjoint, right? So we have to output the current modulo, this one, the modulo value they have given, right? So this one we have to be careful with this. We have to apply strictly this one modulo value. We have to output the count modulo, this one, 9982444353, whatever they have given, right? So this value, right? So let me read the question again. So just listen to this carefully. So we have been given the rooted tree with n nodes, right? So where root equals initially 1 and leaves are the nodes with no children, right? So for any subset of the leaves L, let this one, what do we call, let f of L be the smallest connected subgraph containing all the leaves in L. So what we need to do, we have to count the number of partitions of the leaves into the groups such that for any two different groups x comma y, the subgraphs f of x and f of I are this one, node disjoint. So we have to output the count modulo, this one, 9982444353. Simple. So let me delete this one. This is fair and fine, right? So let's go with a simple example, man. Let's go with this one, input output part. So see here, we have this one n that we have been given 5 and we have the array array of the digits 4 ones, right? So this is nothing but n and this is nothing but the parents, basically parents array, right? So this is nothing but the parents array, 1111 we have. So in simple terms, so this is nothing but n and this is nothing but the parents array or the parent or the parents array, basically. This is fine, 1111. So the output that we need to get here is 12, meaning here this one, what do we call, the number of partitions of the leaves into the groups such that for any two different groups x comma y, the subgraphs f of x and f of I are node disjoint, in this case is 12, basically, right? So this is fine. Let's consider the same example for the approach, right? So first example, so you can just try to implement the same thing for the example 2 within the question, right? So I'll just delete this one. So let me do one thing. Let's discuss the approach. I believe the question part is completely clear. Let's discuss the approach followed by the complexities and then let's write the code as usual. Now, as usual, let's discuss the approach first. So here I have considered the same first example that they have given in the question, right? So this is nothing but the n, this is nothing but the parents, right? So we know this. So the output that we need to get here is 12. So one more thing before getting on with this one step-by-step explanation, I want to tell you one thing, that we'll be going with the dynamic programming along with the DFS, right? So we will be going with the dynamic programming along with DFS, right? In simple terms, DP plus DFS, right? So just keep this in mind. So let's go on with let's move on with the step-by-step explanation here. So n equals 5 and parents equals this one 1 1 1 1 we have. So each leaf here individually can be alone, right? So each leaf here individually can be alone. If a leaf is alone, it's f of leaf, this one whatever I have written in this format. So this is the leaf node only. So this is the leaf node only. So all the singletons partitions is allowed. That's one partition. That's one partition. All the singleton allowed, because see we have here 4 leaves, right? So here we will be considering the 4 singletons. This is fine. Now let's move on with the second point here. So any group that is of size greater than or equal to 2 among the leaves will have the minimal connected subgraph that include the root, right? So if any group of size that is greater than or equal to 2 among the leaves will have their minimal connected subgraph that include the root. If one group is greater than or equal to 2 uses the root, the other leaves must be singletons. So valid partitions are here. In this case, we have to choose any subset S of leaves with S that is greater than or equal to 2, meaning this one has to be positive always. So we have to choose any subset S of the leaves with a S greater than or equal to 2 to be grouped, and every other leaf is singleton here. Just keep this in mind, right? So we will go with this kind of formula, right? So count equals nothing but here number of subsets of 4 leaves with a size that is greater than or equal to 2 plus the this one, all the singleton case, right? So this one will be C of 4 comma 2. So we have 4, and so we will be going with 2 3 and 4, right? So 2 3 and 4, in total we have 4, right? So C of 4 comma 2 plus C of 4 comma 3 plus C of 4 comma 4 plus 1. This is fine. C of 4 comma 4 plus 1. So this will be 6 plus 4 plus 1 plus 1. This is fine. 10 11 and 12. So this is fine. Now we have 12. So the final output that we got here is 12, right? So we'll return this one as output. So the output that we got here is 12, which is equivalent to the output that they have given for the, or that they have mentioned for the example 1 within the question. So our approach works absolutely correct in this case, right? So as we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part, right? So what will be the time complexity here? The time complexity would be this one, big of n, right? So time complexity would be big of n. So what would be the space complexity here? Space complexity would be big of n as well. So the time complexity would be big of n as well. The space complexity would be big of n as well. So why time complexity here would be big of n? Because each node along with each edge basically is processed once within the DFS. So I said we'll be going with the DP along with the DFS, right? So each node along with each edge. So this will be processed once in the DFS, and merging children uses constant time arithmetic per child, right? So this is fine. So what would be the space complexity? So overall space time complexity would lead to big of n. So what would be the space complexity? Space complexity would be big of n because of the adjacency lists also will be making use of the DP table, right? So adjacency lists along with the DP table stores big of n memory. So overall space complexity would lead to big of n. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n and big of n respectively, right? So big of n and this one big of n respectively, right? So now we are completely familiar with the approach. As we are completely familiar with this one complexities, as we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code. So now let's do one thing. Let's quickly start writing the code. I'm in the compiler already. So this one here we'll be making use of the different different utilities as well as the fast input output, right? So let me import input output package as well as the utility package. So I'll just go with Java input output dot star. Also just type here Java dot util dot star. So this is fine. Now let's do one thing. Let's go with public here class this one main, right? So within the main method, let's do one thing. Let's go with a modulus for answers, right? So I'll just go with static So this one final end. So this one mod equals let me go with the mod value man. So this one, right? So let me copy this one entirely. Let me paste it over here, right? So the next thing is we have to go with the number of nodes, also the adjacency list for the rooted tree, also the DP, right? So DP, what do we call that one? DP array, right? So these three things, let's initialize this one faster. So this one will be int, static int n. This is for the number of nodes. Now let's go with the adjacency list for the rooted tree. So this one will be static list. This consists of the integers, right? So this is of the type integer. Let's give the array, or else we will get error. So also we have to go with the DP array as well. So this will be int DP. This is fine. Now, as I've said, we'll be going with the DP along with the DFS. So we will be going with the DP within the DFS itself. Let's go with the DFS that performs a post order traversal. You have to know the post order, in order, and pre-order traversal, right? So now we are performing the DFS, or we'll be performing the DFS with a post order traversal. And let's fill the DP, right? Let's fill the DP for node u as well, right? So I'll just go with the helper method here, DFS static void DFS of this one. I need the parameter u. So within this one, let me go with the simple if condition. If u has at least one child non-leaf, then we have to initialize h of u equals 1. Nothing but we shouldn't go with a group that is touching u at, right? Also we have to iterate over all the children v of u and compute the DP for the child v first, right? So let's see the same thing in the action first. If u has at least one child non-leaf, so let's write the simple if condition. If not of tree of u, or this one dot is empty, this is fine. So somewhere I have messed up something, man. This one extra, or if I have given twice here, this is not required. So if only once, this is fine. Now let's initialize h of u equals 1, meaning here dp of u, this one has to be 2, right? So this one 2 3 4 we went with, if you remember the example. So this one has to be 1 initially, and for loop, because we have to iterate over all the children v of u. So this one int v 3 of u, this is fine. Now let's go with the DFS. Let me pass DFS of u here. This is fine. Now we have computed the DP for the child v first. Now we have to read the current accumulated values for u and the child's values for the easier expression, right? So let me go with fu and fv for this, right? So don't get confused here. So this one will be int fu equals DP of u 0, and also comma gu, this one equals DP of u 1, comma h of this one. So I'll just give here hu. So this one will be DP of u 2. So this is also fine, man. And fv, so this one equals DP of v 0, comma gv, this one equals DP of v 1. This is also fine. HV, this one equals DP of v 2. This is fine. Now what we need to do, we have to combine the child v into the accumulated DP for u using derived combinatorial form, right? So we'll be going with the new g, nothing but new value for g of u after incorporating the child v. Let's see the same thing in the action. So this one is somewhat weird. Let me write this one. You'll get this one. So this one will be new g, else we'll be converting this one to the int finally. So I'll just go with int here. So let me open parenthesis here. So within the parenthesis, what I need to write. So let me go with long here. So this one, yeah, let me type long here. This is fine. Long fu into so this one fv plus gv. This is fine. This is fine, man. Now let me go with this here. This one is fine. Long gu and 2. So this one will be long. This is fine. gv left shift 1. Also let's go with plus. Again, let me make use of long here. So this is fine. I'll just go with fv plus hv. This is also fine. Finally, I'll just go with here. Didn't I miss one more of this thing here? What do we call? This is fine. Now let me go with this one, modulo mod. This is fine. Finally, we are done with this part, man. Right? So now we are done with what do we call? Sorry. New g, basically, meaning new value for the g of u after incorporating child v. Also we will be going with a new f, nothing but this is new f is nothing but the new value for the f of u after incorporating this one child v, basically, right? So let me copy the same thing and make the necessary changes, or let me type this one, and new f equals again int. So this one is fine. So let me do one thing. So here this is the wrong thing I did, I believe. Just give me a second here. So I didn't mention one more this thing here. So I would have got the error, man. So let me give parenthesis over here. This is fine. Now we have the correct this thing. So from this one I got to know the error. So this is fine. Let me pass long here. This one will be fu plus sorry, not plus, basically into. So this one will be gv plus hv, right? So gv plus hv we have. This is fine. And again, let me add here this one same. Let me pass long here hu. This is also fine. So this one will be fv plus gv. So this is also fine. Finally, modulo mod. This is fine. So we are done with this part, right? So we are done with this part. Also, we have to go with a long new h as well. So we have went with new g, new f. Now let's go with the new h. So this one new h is nothing but the new value for h of u after incorporating child v, right? So this one has to be in new h equals, again same thing. We'll be going with int here. Let me open this one. Parenthesis. So no need of one more parenthesis here. This one will be long. So this one will be hu. This is also fine, into gv plus hv. So this is also fine. Now yep, finally modulo mod. So this is fine. We are done with this part. Yep, we are done with this part. So finally what we need to do, we have to store the updated accumulated values back to the dp of u, meaning, so I'll just go with dp of u 0. This one, let me assign this one to the new f. Same goes for the new g and new h as well, right? So instead of 0, we'll be going with 1 and 2 values. So this one will be new f. So let me copy the same thing over here. This one. So this one has to be dp of u1, and this one has to be dp of u2. This one will be new g, and this one will be new h, right? So this is fine. Now we are done with this part. Else what we'll be doing, so within the else, so I'll just give here dp of u 1. Let me assign this one to the 1. This is fine, right? So this is fine. Let me come out of this one entirely. So this is it. So we are just going with a leaf node case, right? So g of leaf equals 1. So dp of u0 and dp of u2 stays 0 for the leaf. Just remember this one, right? So we are just going with g of leaf equals 1. So now this is fine. We are done with this part, the DFS part, basically completely. So now we are left with the sum of the input output part, and we will be making use of that DFS within the main method, right? So let's go with the main method. So I'll just go with main here, main method of the function. So this one, let me delete this one. I just go with throws exception. So within this main method, first let me go with here buffered reader. This one br equals new buffered reader, new input stream reader. So this one, let me give system dot in here. So this is fine. For the output, let's go with a print writer. So this one, let me go with out new print writer of new buffered. This one will be writer of new output stream writer. So this is fine. This one will be system dot n. This is fine as well, right? So this is fine. Now let's do one thing. We have to read the n. So we have been given n here, right? So this is fine. N equals 5, and we have 1 1 1. This is fine. How can we write that one? This one will be n equals integer dot %. So this one will be buffered reader dot read line. So this is fine. Yep. We have successfully read n. Next, what we will be doing? So we will be going with a one indexed array, right? So we'll be creating the array of lists. So this one will be tree equals new array list of this one n plus 1. So this is fine. So this is one indexed, and we are creating the array of lists here, right? So now let's initialize the adjacency list as well. So this is very important. Let's initialize the adjacency lists here. So this one will be int I equals 1, I less than or equal to n, and I plus plus. So let me go with tree of I equals new array list. This is fine. Yep. Next, we'll allocate the DP table with the 3 states per mode. Meaning, I can just write it on this way. New this one int of n plus 1. This one, let me give 3 here. This is fine. Now, so let's go with the string tokenizer, man. We have to read the parents p2 to pn, right? So for that, we require the string tokenizer. So I'll just go with string tokenizer here. This one I'll consider st equals new, this one string tokenizer, this one buffered reader dot read line. This is also fine. Yeah, we are done with this part, right? So let's go with the iteration part of the for loop. So this one will be int I equals to I less than or equal to n. So this one will be I plus plus. So this is fine. So this one will be int u equals integer dot this one will be % string tokenizer dot next token. So this is fine, man. Yep. So now we went with the parent of the node I. So now what we'll do, let's add I as the child of u, nothing but the rooted tree. So this one will be tree of u dot add of this one I, right? So this is fine, man. Now I'll just do one thing. So let's run the DP from root 1 by making use of the DFS, this one helper method. So I'll just go with the DFS. So we have already written the DFS helper method, right? So this one I'm speaking of the same thing. I'm making use of it within the main function or the main method. So we have to run, or we are running the DP from the root 1 here. This is fine. Now what we'll be doing here? So answer is nothing but g of root plus h of root. We know this one, right? So we have to print the answer, right? So how can we write that one? I'll just go with the out println. So this one will be dp of 1 1. So this is fine. Dp of 1 1 plus dp of 1 2. This is fine. Dp of 1 2 modulo. Let me pass mod here. So this is fine. Next step is let's flush the output, meaning I can just make use of the flush, or I can just go with the close. I'll just go with the flush itself. So this is fine. This is it for the code basically, right? So before checking the code with different different inputs, let me copy paste the signature starter template. Just give me a second here. So I'll just come here. Let me paste this one entirely, man. This is fine. Yeah. Now let me come to the question. So I'll just copy this one. This is fine. We have to get the output. Well, let's check the same. So what is the error? We have one warning and one error. Print writer out equals print writer, new buffer writer. What happened here? Hey, new buffer writer I have made use of. Yeah, this is fine. New buffer writer of new output stream writer. This is fine. Correct, right? What is wrong here? New print writer. New buffer writer, new output stream writer. Of system dot. Oh, this one has to be system dot out, not the system dot in. So this is for the output, right? So this is fine. Let me hit the run button. So we have the error here. Warning, unchecked conversion. So output we are not getting it, right? So this one on the line number 69, where tree equals, and we have considered this is fine. Accordingly with the input we have considered and assigned this one. This is fine. Tree equals new array list of n plus 1. This is fine, right? Meaning, so we are just this is one indexed and we are creating the array of list. What is wrong here? Wait. So let's do one thing. Let's check what is wrong here. So what mistake I have done here is, so when I check this one in the line number 31, basically line number 31 and 32. So basically in the line number 32, what is happening? So we have to recurse on the this one v. We don't have to recurse on this one u again, right? So we have to recurse on v basically, or else we'll be definitely getting the error. So this is the critical mistake. So I hope if I run this one now, yeah, we are getting the output. Well, we can just ignore this one for now, right? So this one, what do we call a warning? So now we are getting the correct output, right? So 12. Now let's check with this input. The output that we need to get here is 1. Let's check the same. So yeah, we are getting the correct output 1. Let me do one thing. Let me copy this problem entirely. Let me copy this solution entirely. Let me hit the submit button. You can just go through the diagram. They have given us wonderful this one example here. So in the first example, the leaf nodes are 2, 3, 4, 5. The ways to partition the leaves are in the following image. You can just look into it. So they have given us wonderfully, just for the sake of understanding. So let's see. Let me come to the submission part here. F, right? So yeah, problem F, leaf partition. So let me paste the code here and let me hit the submit button. So this is kind of difficult, man. This is kind of really difficult question. So this is fine. We just have to know this one DFS and how to apply the DP within the DFS. So this is fine. They have given us the mod value as well. Yeah. On spot, this is kind of difficult to implement. I'm not gonna lie. Yeah. In that this one toast, it was showing accepted, right? So this is fine. The verdict that we got here is accepted, right? So we have made use of the pure DP here along with the DFS basically, right? So we are going with the dynamic programming along with the DFS to solve this particular problem. I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.